All right, good morning, guys. Welcome to this physics video. I will explain you the situation first, and I'm going to tell you what are the mistakes a lot of students will do when attempting this question. So first, read this question: a block of ice, moves down a frictionless ramp, and it gains some kinetic energy. It is associated with some force, and which is 50 newtons. The block slides through a distance of 0.50 meter along the ramp. Its kinetic energy increases by 80 joules. How much greater would its kinetic energy have been if the rope had not been attached to the block? So very important. The key word for me in this whole thing, is obviously I am thinking about the concept which I need to apply in the back of my mind. But very important point which a lot of students don't understand is this part of it, which is the block is going down, right? The block is going down. This is very important to understand. If you don't understand this, you're likely to get this wrong. The block is going down. So if you look into this problem and I draw the situation number one, let me draw the free body diagram. This is what it is. So you have a force which is upwards, a gravitational component which is acting down, and the block, the net result is that the block goes down by 0.5 meters. So if you look into this block is influenced by a force which is upwards, and then of course it is influenced by the component of the gravitational force which is trying to bring it down. The net result is it still goes down. So this force wins the tug of the war, right? So this force, and it's very important that you read this question very carefully because the block is going down. And very importantly, this surface, which is between the incline and the block of ice, is frictionless, right? This is also very important to capture. Some questions could have a friction given in the situation, right? You should be wary of that. Let's put the data here. The force which is on the block is the 50 Newton force. The angle of the incline is given to be 50 degrees, okay? And the energy, the kinetic energy in the situation number one, which results from the net, winning of mg sine theta against f, and when it slides down by 0.5 meters, is 80 joules. Kinetic energy is equal to 80 joules, right? This is your net gain, situation number one. Now, in the situation number two, and of course, this is moving along the inclined plane, but against the direction. So this is an anti-parallel force. Then you have mg sine theta, which is trying to bring down the block along the inclined plane like this. Situation number one. Situation number two, if I draw the situation number two, this is the way situation number two looks like, right? So this is your block. Now this force no longer exists. You just have a gravitational component which is going down. This is so when I write the data for this, my incline angle has not changed. Theta is still 50 degrees. My kinetic energy is something I need to find out. So the force is not force is absent now. There is no upward anti-parallel force, right, which is trying to pull it up against its net 0.5 meters, right? That's what is required to be calculated. In the absence of this force, there is no rope which is connected. It's very important to understand the second situation. It goes on its own through the gravitational force, and therefore the gain in kinetic energy is different when it moves through a 0.5 meter distance as compared to a situation where there is an opposing force here. So kinetic energy has to be calculated. There is no force. What exists is mg sine theta, which is trying to bring it down parallel to, and of course the displacement in both the cases, right? The displacement here is 0.5 meters, the displacement is 0.5 meters. So if you look into the parameter, the only difference is the force of 50 Newton is missing in the situation number two, right? Now the concept, right? It is very important that we revise the concept. That the concept obviously is that if you do positive work on the body, the kinetic energy goes up. If you do negative work, the kinetic energy goes down. In situation number one and situation number two, the kinetic energy has gone up, right? In the situation number two, you have to find out how much is the kinetic energy gain in the absence of this force. So let's discuss, what was this force doing to this block? This force was trying to pull up the block, but whereas the net displacement is zero point 0.5 meters. So these two, the 0.5, the force of 50 newtons and the displacement of zero point 0.5, these are anti-parallel at an 180 degrees. So the only contribution which this force was bringing in on the table is negative, right? So this was doing some negative work, and therefore it was neutralizing the positive efforts of this gravitational component of the force. The gravitational component of the force is doing positive work because the displacement is in the same direction as the mg sine theta. This is there, but in the case of force, the force is upward. So what was force doing in situation number one? The situation number one, the force component of the work, which was a negative work, probably reduced the gain in kinetic energy to 80 joules, right? Which is a big loss. But in the case of situation number two, the loss making proposition of force, is missing, and therefore the kinetic energy gain should be more as compared to situation number one. The negativity, let's put it this way, of the situation number one, which was reducing the kinetic energy because it had a negative work component. This force has negative work associated with it because it is going up, and the net displacement is still downward, right? So if we were to write the equations, I will write the equation. So the mg sine theta, minus F is the net force on the block, right? If you look into this free body diagram, downward force which contributes to positive work, upward force which contributes to negative work, multiplied by zero point 0.5 results in 80 joules net gain of work or kinetic energy, right? The positive work which this produced gets converted to gain in kinetic energy. In the situation number two, it's mg sine theta multiply by 0.5. So the negative component is gone. You have to find what is this. So let's put it as x, right? So mg sine theta into mg sine theta into 0.5x is x. I want to substitute mg sine theta into half is equal to x. So which is equation number two in equation number one. So I will just put it there, right? I will just open the bracket of 1. So I'm just solving 1 now. So mg sine theta multiply by 0.5 minus f into 0.5 is equal to 80 joules. This quantity is unknown to me. This is x, right? And I need to, and what is this quantity, by the way, if you were to just define this, right? This is the same quantity as this, which is the work done by the gravitational component minus F into 0.5. F is how much? We can do a substitution here. 50 newtons is equal to 80. X is equal to 80 plus 25. 15 into 0.5 is equal to 105 joules, right? So in the absence of this negative force, the kinetic energy gained or the work done by the gravitational component is 105 joules, right? Which is a big change. Right. So let's go back and see what is the question. The question is, how much greater would the kinetic energy have been if the rope had not been there? So how much greater? So which means they're asking about the difference. Earlier, you just gained 80 joules. Now you just have 105 joules when the rope is not there. So how much greater would your kinetic energy be? 105 minus 80 is equal to 25 joules, right? So your gain, the extra gain, because the negative component of the work done due to the upward force is missing, the greater, how much greater your kinetic energy is going to be? 25 joules is your net answer, right? So this is a precise answer. Obviously, we're doing a lot of qualitative discussion, but let's not get distracted by those. The focus is reading the question very importantly. They're not asking you to find out the new kinetic energy. They're asking you to calculate how much greater would its kinetic energy have been if the rope had not been attached to the block. So reading the question is very important, and a lot of students miss the point because they did not read the question. Now what I'm going to do is I'm going to summarize this whole discussion and give an example as to what is the approach you need to take to solve similar questions. Thank you very much. That is just to give you a qualitative aspect. So always when you're doing the questions, look for different forces acting on the body, right? So if I were to summarize this, I will summarize this, giving you some more examples on, how you could probably think, and this concept should be clear in your mind. So if I have a block of mass, and I have a force getting applied like this, I have a force getting applied like this, I have a force which is getting applied like this, I have a force which is getting applied like this, I have a force. So I have numerous forces, and the net result of this is that the block moves in a particular direction by say 1 meter, in positive direction, and gains some kinetic energy in the process, right? What I have to do is I have to look at individual forces F1, F2, F3, F4, F5. What I need to do in step number one is do components of the force, right? So this angle is say 30 degrees, this angle probably is 150 degrees, this angle is 90 degrees, this angle is maybe 180 degrees. It's anti-parallel to the displacement. What you do is pick up individual forces. So I'm just summarizing. Pick up individual forces, all right? Resolve the forces in x and y coordinates, right? Resolve everything. So if you have F4 at 150 degrees, resolve it in two components, 1 and 2, right? Step number 3, after resolving, all the forces which are perpendicular to the displacement, right? Now the work done is 0. Now put work done is equal to 0. This force has no work done. The component of F4, which is this particular component, the y component, has no force. So the component of F2 in the upward direction has no work done because the displacement is in this direction, your force is in this direction. No work done. This force has no work done. F3 has no work done, right? So first eliminate the forces which are doing no work. Step number 4, let's concentrate on the forces which actually do some work, right? So F1 is in the same direction. So then concentrate on forces. Now concentrate on forces which do the work, right? Step number 5. Now split these forces in two categories. Split these forces into two categories. What two categories are we referring to? So for example, F5 is an anti-parallel to the displacement. F5 is in this direction and 1 meter is in this direction. So once you split these two categories, divide the two categories as anti-parallel forces, and parallel forces. Parallel forces means the forces which are parallel to the direction of the displacement. A force like this, F1, is parallel to the displacement, right? So parallel forces. Now the anti-parallel forces, they contribute to negative work, right? So add all the negative works, say, okay, so anti-parallel forces, AF, and parallel forces, force number 1 contributes to, just hypothetically, minus 30 joules, minus 20 joules, minus 10 joules. Add all of these. Parallel forces add 80 joules, 50 joules, 15 joules. Add all of these. So you get a minus 60 joule here, and you get a 130 and 145 joules. The net work done, is the sum of the work done by anti-parallel forces and parallel forces, comes out to be 100 and whatever the sum is, 145 minus 60 is equal to 85 joules. So the result of all these forces working on this block of mass results in a positive work of 85 joules, and therefore this block gains a kinetic energy of 85 joules. As a next step, what you could probably do, if you know the mass of the block as maybe 1 kg, you could find out how much is the final velocity of the body once this block has moved by a distance of 1 meter, probably, right? So 85 joules is equal to half mv squared. Net gain, put mass is 1 kg, find the velocity of the body at that instant, right? So you could, so the examiners could, test your level at multiple levels, and you have to peel the onion. But we be very careful that you read the questions. In this particular question, the body was going down. That was very important to understand. If the body was going up, you could probably, do some testing on your concepts. If the body is going up, what exactly would the force look like if the gain in kinetic energy is this much, and so the examiners can test you on multiple things, but you should be clear in your mind about the concept of work, positive and negative, the concept of inclined plane, and how all of this comes together to help you solve the problems, right? So I hope this made sense to you and you were able to understand the summary of the discussion we had and the approach you have to take while you solve this problem. This was the only channel probably which focuses on going an extra mile in making you understand the concept and not do a run-of-the-mill solutions job only. So we're here to explain you. We're here to help you solve the problem, understand the problem, give you a larger perspective to the problem solving, so that you can become independent and solve the problem. So if you like this video, press the subscribe button, and thank you very much for your support. I have 2,000 videos on this channel. Don't forget to miss any one of them. I'm doing a lot of stuff from university physics, wrestling holiday, and some Indian books. The physics does not change. I may be speaking in different languages, but if you listen and just see, how I solve the problem, you will get the essence of it. So don't let the language become a barrier to physics. You could still watch a video even if it is in some Indian language, because the physics of it does not change. There is a particular way we have to solve the problem. I follow all the steps, all the concepts are explained. Even if you don't understand the language, just watch me solving, right? Wait for my next video. Don't miss any of my solutions and explanations. For all you know, this may be your next question in the examination. Thank you very much.